Hello everyone, this is Kalpana here. In this video, we're going to see a problem from partial differential equations. So let's get going. Problem: form the partial differential equation by eliminating the arbitrary constants from z equal to ax e power y plus 1 by 2a square e power 2y plus b. So here we are given a relation or an equation z equal to ax e power y plus 1 by 2 a square e power 2y plus b. Consider it as equation number 1, right, which involves arbitrary constants a and b, right, and z is a function of x and y. Where x and y are independent variables, we can call z as a dependent variable otherwise, right. Now we are asked to form a partial differential equation by eliminating arbitrary constants from y. So for that purpose, what we'll do is we'll just partially differentiate one with respect to x and with respect to y. Okay, firstly we'll begin with the detailed explanation, or so we'll just form PD in a detailed process, and later we'll go for the shortcut just by reducing number of steps. Partially differentiating one with respect to x. So here we are partially differentiating one with respect to x, so that we'll treat y as constant. Just apply dou by dou x on both sides of 1. Which gives us dou z by dou x equal to, since we are partially differentiating with respect to x, so we'll treat y as constant. Okay, dou by dou x of second term, dou by dou x of last term or third term. Since dou z by dou x equal to p, let's use this notation and replace it by p. You'll get p equal to constant a e power x a e power y into dou by dou x of x. Since y is treated as constant, so e power y is also treated as constant. Okay, plus constant 1 by 2, or we don't have terms in x here, so we'll treat everything under this brackets as constant. So partial derivative of constant with respect to x will be 0, plus partial derivative of a constant with respect to x is 0, right, which gives us p equal to a e power y into partial derivative of x with respect to x is 1, which gives us p equal to a into e power y, or bring this e power y to LHS to find a. Okay, I'll just leave it like this. Consider as equation 2. We got equation 2, which is p equal to a e power y, or equation 2, right. We'll save it for further. Now partially differentiate 1 with respect to y. Since we are partially differentiating 1 with respect to y, so we'll treat x as constant. Apply dou by dou y on both sides of 1. This gives us dou z by dou y equal to partial derivative of first term with respect to y, partial derivative of second term with respect to y, partial derivative of third term with respect to y. Since we have notation dou z by dou y equal to q, so we'll replace LHS by q. We'll get q equal to constant into dou by dou y of e power y plus constant into dou by dou y of e power 2y plus partial derivative of a constant with respect to y is 0, which gives us q equal to ax into partial derivative of e power y with respect to y is e power y plus 1 by 2a square into partial derivative of e power 2y with respect to y is 2 e power 2y, which gives us q equal to ax e power y plus 2 gets cancelled and you'll get a square e power 2y. Okay, consider as equation 3. Now observe 1, 2 and 3. See, in 2 and 3 it does not involve any b, right? So by substituting 2 and 3 in 1 also, this b won't get eliminated, right? So now what we'll do is we'll just observe 2 and 3. Well, we'll use 2 and 3 to find partial differential equation here. We have 3, q equal to ax e power y plus a square e power 2y. Okay, I'll write this as a square into, we'll write e power 2y as e power y whole square. Okay, now I'll write a into e power 2y together, and I can write a square e power y whole square as a e power y whole square, right? Since by 2 we have p equal to a e power y, or better a e power y equal to p. So I'll just replace a e power y by p, since a e power y equal to p. Just replace these two by p, you'll get q equal to xp plus p square, right? Therefore q equal to xp plus p square. See, it does not involve any arbitrary constants, and is also, this equation is also of the form f of x, y, p, z, p, q equal to 0, right? It involves q, x and p, right? So this is the required partial differential equation. Therefore q equal to xp plus p square is the required partial differential equation. This completes the problem. Now let's see the shortcut just by reducing the number of steps while finding partial derivatives of 1 with respect to x and y. Partially differentiating 1 with respect to x, dou z by dou x equal to a e power y into partial derivative of x with respect to x is 1 plus partial derivative of a constant with respect to x is 0 plus partial derivative of a constant with respect to x is 0. Since dou z by dou z by dou x equal to p, let's use this notation. You'll get p equal to a e power y, right? We have considered as equation number 2. Now partially differentiating 1 with respect to with respect to y. Dou z by dou y equal to ax into partial derivative of e power y with respect to y is e power y plus 1 by 2 a square into partial derivative of e power 2y is 2 e power 2y plus partial derivative of a constant with respect to y is 0. We'll use the notation dou z by dou y equal to q. You'll get q equal to ax e power y plus a square e power 2y, right? Which is considered as equation 3. Now we'll observe 1, 2 and 3. By observing 1, 2 and 3, we can say that by substituting 2 and 3, the arbitrary constants cannot be eliminated from 1. So what we'll do is we'll just observe 2 and 3, and we'll pick 3. We have 3. Q equal to a e power y into x plus a square e power 2y square can be written as a e power 2, a e power y whole square. Since p equal to a e power y by 2, so I will use this. Therefore, q equal to px plus p square is the required partial differential equation, which completes the problem. See, this is a shortcut. Only few can understand, not everyone. Well, we have seen a problem from partial differential equations in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.